Okay, in this video we are going to talk about empirical and molecular formulas. So first we're going to talk about what the heck they are and then how the heck you calculate them. Alright, so let's talk about empirical formulas first. An empirical formula is the simplest formula for a compound, meaning it's written in the lowest whole number ratio of elements that are in the compound. So an example of this: if you have, say, glucose, C6H12O6, its empirical formula would be CH2O. So that's its empirical formula, because it's showing me the lowest ratio of the elements in a compound. And a lot of elements, especially when you get into organic chemistry, or a lot of compounds have the same empirical formula, but different actual chemical formulas. So a molecular formula, this is a molecular formula. A molecular formula is the actual formula for a compound. So it's not written in its lowest whole number ratio, it's what's actually in the compound. So another example, you have two compounds here, propane, which you burn in to make burgers in the summer, in your grill, and then another common organic compound, hexane. These are the molecular formulas for these two compounds, but they share an empirical formula of C3H8. So both of them, their lowest whole number ratio is the same lowest whole number ratio, so they both have the same empirical formula. All right, so let's talk about how to calculate both an empirical and a molecular formula. So we'll start with empirical formulas. How would you calculate this? All right, in order to calculate empirical formula, you would need percent composition by mass data for the compound. And so, for example, you have a compound and it's been analyzed and found to be composed of the following percentages: 17.6% sodium, 39.7% chromium, and 42.7% oxygen. And it's asking for its empirical formula. Well, these are mass data percentages, meaning that whatever amount of sample we have, 17.6% of the mass of that sample will come from sodium, 39.7% of the mass of that sample will come from chromium, and 42.7% of the mass of that sample will come from oxygen. And so to make this simple, we're going to assume we have 100 grams of this compound, because that way, when you multiply the amount of compound you have by the percentage, it really just ends up being the same number. So 17.6% of 100 grams is 17.6 grams. 39.7% of 100 grams is 39.7 grams, and 42.7% of 100 grams is 42.7 grams. So now we have our masses of the elements that compose this compound. So we know our compound is going to contain sodium in some amount, chromium in some amount, and oxygen in some amount. And I hope you know that these amounts that go down here, or these subscripts that go into our chemical formula, are actually mole ratios, not mass ratios. So the next thing we would need to do is then convert these into moles from mass. So I'm going to go ahead and use their molar masses to do that, and we end up with these mole quantities. So 0.7656 moles of sodium, 0.7635 moles of chromium, and 2.669 moles of oxygen. Now, the issue becomes that, remember, in our chemical formula, these mole quantities down here need to be in whole numbers. These are not in whole numbers. So what we're going to do is we're going to figure out which one of these is the smallest mole quantity. It's this one. And we're going to divide each of them by the smallest to get a better or more whole number ratios. So we'll divide each by 0.7635. Remember, because that was the smallest one. and you get approximately 1, 1, and 3.5. Now again, there's an issue because these need to be whole numbers, and a lot of times these will, at this point, these will actually work out to be whole number ratios. But for this particular problem, they didn't end up being whole number ratios. So what we're going to do is we're going to multiply each of these, this 1, and this 3.5, by a small common multiple so that they all end up a whole number. So 2 should do it. So if I multiply them each by 2, then that should give me whole numbers, 2, 2, and 7. So I'm going to scooch this up, and from here we should be able to figure out what our ratios of sodium and chromium and oxygen are. There are 2 sodiums, 2 chromiums, and 7 oxygens. So that makes this our empirical formula. All right, let's talk about how to calculate a molecular formula. So to calculate a molecular formula, you have to be given some information. So you're either going to be given the empirical formula, or you're going to be giving info to calculate the empirical formula, and then you're also going to need to know the molar mass of the molecule. So, for example, this is a really simple one. You're asked to determine the molecular formula for a compound, and it gives you its empirical formula, NH2, and it also gives you its approximate molar mass. And so for this one, we'll write some steps. First thing you're going to want to do is find the molar mass of your empirical formula. And so we have NH2, and its molar mass is going to be equal to about 16.023 grams. So approximately 16 grams. You can round at this point because we're just trying to get an approximation. So what you want to do is you're given, again, a molar mass of the compound, and now we have a molar mass on its empirical formula. So you just want to see how many times that goes into that. So you're dividing your molar mass that you were given for your molecule and by your empirical formula's molar mass. And you're going to get approximately 2. So what that tells me is that my molecule weighs twice as much as my empirical formula. So from here it's easy because it just becomes a matter of, you know that you've got twice as much of everything. So N2H4. We're going to multiply our subscripts down here by this factor. And this is now your molecular formula. Now, I like to double check and to make sure that the molar mass of my molecule that I just got here matches the molar mass they gave me in the question, just to double check and make sure I did it right. And when I do that, I get a molar mass of 32.014, like an exact molar mass of 32.014. And that is close to what they gave us in the question, so I know that I've done my my molecular formula correctly. All right, and that is how you calculate empirical and molecular formulas.